Hello, I am ZHAO Chuang. Let's talk about Caroline the Corythosaurus, a well-known large hadrosaurid dinosaur that lived in North America during the Late Cretaceous. This genus belongs to the Lambeosaurinae, a subfamily of hadrosaurs. A notable feature of this group of dinosaurs is that their head had a crest, and their neck was very long, much longer than that of flat-headed hadrosaurs. The top of their head was also more complex than the latter. These dinosaurs were huge and robust. Their body length could grow up to 8 meters. Some large specimens could even reach 10 meters. Hadrosaurs such as Corythosaurus often walked on all fours. When people first discovered this type of dinosaur, the earliest restorations mistakenly thought they walked on 2 legs, because fossils always display thinner and weaker forelimbs in contrast to their thick hindlimbs. So, some early theories suggested that they might often walk on their hind limbs. At the first discovery of hadrosaurs, only one extant animal, the kangaroo, was reminiscent of a similar structure. Therefore, some old restorations shaped it into such an image, with its 2 hind legs standing upright, and its tail as a support. However, we now know they couldn't do that. Its tail was not as soft and swimmable as previously thought. Because the tails of hadrosaurs were flat-sided with very tall neural spines, some early studies believed their tails could help them swim in the water like fish. Therefore, for a long period, people thought hadrosaurs were aquatic and used their flat-sided tails to swim forward. Other fossil evidence shows that its forelimbs were webbed, which were considered to assist swimming. However, current research has overturned this theory. Its tail, albeit very thick with tall neural spines, was far less robust than the commonly seen crocodile tail, not strong enough to swim. Its tail still looked relatively thin as a whole. Since the lateral transverse processes were relatively weak, its tail couldn't attach massive muscles to propel the body powerfully to swim forward like a crocodile. We now know its forelimbs were actually wrapped in a huge fleshy glove. The so-called webs discovered previously are the flesh enveloping the hands. It had a huge hoof at the end of its fingers, like the one shown in this model. This structure was absolutely used for walking on land, not swimming in the water. Numerous footprints also indicate that this dinosaur inhabited the dry land, and its tail did not drag on the ground like what the old reconstructions presented. No trace of the hadrosaur tail dragging has been left among the large number of footprints. Let's take a closer look at the other details of this dinosaur. The first is about the head. The most striking feature of Lambeosaurines is that they had a crest. Corythosaurus is very famous among them. It had a large head and a slender face. Looking top down, you will see that the anterior end of its mouth swells to both sides like a duck's bill, and the middle section is very narrow. This is why we also call hadrosaurs the duck-billed dinosaurs. But when it was alive, the front of its mouth was not as shown in the skull. It had a keratinous beak that extended downwards. A ridge at the foremost of the beak made this part very pointed, like a bird's beak. They would use this structure to forage leaves. Inside its mouth were rows of teeth that helped it chew. Hadrosaurs chewed food differently from humans. When we eat, we move our jaws from side to side and use the teeth surfaces to grind the food. However, this was not the case for hadrosaurs. Their teeth will be what this model displays. From a front view, the upper teeth look like this, and the lower teeth look like this, creating a slant friction surface here. There were several rows of teeth in the upper jaw and the lower jaw. Such a dentition will form a washboard-like structure. When it closed its mouth, the lower jaw would press against the inside of the upper teeth, and propped the 2 maxillary bones to lateral sides, resulting in a friction effect like this. It used this method to chew and grind diagonally. If you have the opportunity to see a living hadrosaur, you would see the upper part of its face bulging like this when eating. It had very large nostrils, which presented a slender shape from the skeleton and extended all the way to the inside of its crest. The eye-catching crest was a hollow structure with complex air chambers inside. Scientists now believe that the crest might function as a display, as its surface might be in a bright color, formed by the keratin that wrapped outside the bone when alive. In addition, the air chamber connected to the nostrils would use the crest to resonate when it wanted to make sounds, producing loud and complex sounds. This may be another significant role of the crest. Just below the crest were its tiny eyes. Besides, please pay attention to its crest. Its crest wasn't a circle directly integrated with the top of the head. Here, at its posterior, there is a gap between it and the skull, resembling an axe resting atop the head. This crest did not appear in childhood but developed in adulthood, so its primary function was likely for display. What's more, when it was young, its calls might greatly differ from adults. This is also a salient feature of this type of dinosaur. As a Lambeosaurine, it had a long, curved neck like a swan, with more cervical vertebrae than the flat-headed hadrosaurs. Therefore, its neck was slender and more flexible. In previous restorations, you can see that people often drew this dinosaur's neck to be slim and elongated, like a swan. But now we know that the dorsal and ventral sides of this type of dinosaur's neck have massive muscles, making its neck stocky, resembling a horse. And its cervical vertebrae would curve inside to form an S shape. Lambeosaurines tended to have very tall neural spines. When alive, their neural spines were covered with numerous delicate interlocked bones from the back to the tail, which caused their caudal and dorsal vertebrae to be inflexible, and could only move in a small range. These ossified tendons strengthened their back to form a structure similar to an iron fence gate. When it was in locomotion, these bones would move under the muscle and skin, giving it a certain flexibility but far from the degree of bending without these structures. Therefore, when this dinosaur walked, its back was still pretty straight. Its pelvis, the upper ilium of its pelvis, was very long, indicating that when it was alive, its thighs might be very thick and stout, with massive muscles attached to the legs from the pelvis to the femur. The lower ischium of the pelvis was also slender and extended backward, making its body broad. Next, let's look at its forelimbs. Although we mentioned that its forelimbs ended with a hoof, it had 4 fingers. Its thumbs were vestigial, and this hoof was composed of 3 fingers, and there was a tiny 5th finger, equivalent to the human little finger. This little finger was believed to function to grab and deliver food to the mouth. Now, it seems unlikely to play such a role, and it might be in a degenerating stage. The thighs of its hind limbs were very stout. Its calves were also muscular but much slimmer than its thighs. It had only 3 toes, like those of a hadrosaurus, but much shorter than their ancestors, the iguanodonts. The bones of each toe were significantly shortened. The structure of the sole is like this. A very thick pad was under each toe. These pads would form the shape of the Chinese character shan, or the shape of the capitalized letter E, with all 3 toes facing forward. A pad under each of these 3 toes and another pad behind the toes form a plum blossom-like shape, somewhat like a dog's paw. This is a typical feature of the soles of hadrosaurs. We can get this information from fossils. Finally, let's talk about the skin of this dinosaur. Many skin impressions of Corythosaurus have been found, mainly from the flank and underside of its body. The skin impression of its flank displays a large number of delicate scales. Each scale is only a few millimeters, covering the whole body, making its body in a smooth state. Some well-preserved fossils show a lot of longitudinal folds on the Corythosaurus body sides, indicating that the skin here was often squeezed when this dinosaur walked. This skin impression is likely from the front of the thighs. This is because its thighs and torso were wrapped by a piece of skin, like many extant birds, and when the thighs kicked forward, this part would be squeezed, and such folds would be formed here. These stripes could also enable the thighs to move forward better. Moreover, on the underside of the Corythosaurus body, With the fossils mainly from the bottom of the tail, many coin-sized large scales arranged in neat rows can be seen. We don't know yet whether these scales also appear on its front half, but because they have been found on the underside of its tail, we can infer that they may protect its belly to a certain extent, and extend to its front body. Good. The above concludes our introduction to Caroline the Corythosaurus. Thank you all.